Then please share the rights with me.
Yes, yes, certainly. Yes, we are live now.
Okay, perfect. So, very good evening, everybody, and I welcome you to this joint webinar by NASCOM FutureSkills Prime and Google Cloud. We have not started the session yet, and you can see that on your screen. So please stay tuned. And in the meantime, you can also ask your friends and colleagues who are registered on this course to join for this session. We'll give another 2 minutes for the people to join in, and then we can begin the session. Okay, I think we have participants joining in. So a few house announcements before we start the session. One is that as participants, you would notice that there is a Q&A tab at the bottom of your computer screen, and that we have as a part of our Zoom meeting. At the end of this webinar, we'll open up the slot, and if required in the middle of the session as well, whenever you have doubts, you can raise your questions. You feel free to post your questions on the Q&A tab, and we'll be actively taking them up during the session. And if you wanted to speak up and ask something about, technical about the course, so we have our experts today, and you can speak to them one-on-one and raise your questions, raise your doubts. Even if you are struggling with the redemption of your additional credits that have been allocated to you, still you can raise your questions in the Q&A tab, and as well as by raising your hand. So all of these facilities have been provided by Zoom. So thank you very much for everybody who has joined in. So we'll get started now. Let's start with a quick round of introductions. So myself is Akash Kumar, and I'm from NASCOM team. I manage industry partnerships for FutureSkills Prime, which means that we have partnerships with many technology majors across various technologies in India, and we work towards onboarding training from these tech companies in the emerging technologies to FutureSkills Prime platform. That's my role at NASCOM. We are very proud to bring you today our association with the Google Cloud team, and I take this opportunity to introduce members from the Google Cloud team. We have Sri Sweta, who is managing the particular program from Google Cloud side, and she's the program manager for Google Cloud. We also have Mr. Jiten Kumar Chan, who is the technical expert available today and coming up with a massive experience in the industry, and have been working with the modernized and secure infrastructure within the Google Cloud ecosystem. So as you see, we have the webinar starting up soon. So let's take a minute to talk about NASCOM. So FutureSkills Prime NASCOM has been existing since quite a while now, and the sole objective of NASCOM under the Ministry of Electronics and Information Technology has been to skill the India as a mission of the government, and as a mission that we all have taken up. We want to impart skills to the upcoming generation who are in their graduates, undergrads, and postgrads. We offer them courses from various technology majors and help them skill up, which is also a part of agenda of NEP 2020. And that's why you are here and you have been offered this course. You have registered for this program, and you must be doing it successfully, and maybe very soon you'll look forward to complete it as well. So So digital talent has become a mission critical for India. So there is available of technology, and digital fluency is very much required, even if you are not a technical person, but at least you have to be digitally fluent in order to survive in the digital environment that we have. Everyone uses mobile phones, everyone uses laptops and other devices, for which you have to have knowledge about how to operate these devices, which is all falling under digital fluency, and that's part of the your mission to comply with the technology. So there's a huge opportunity, and the challenge is that there's a gap. There's a huge gap as well. So what students and people learn in their existing ecosystem of their college, of their university, is not actually 100% complying with what industry needs. So so that is where the gap comes up. I'm sorry, I have a bad throat. So in order to fulfill that gap, NASCOM has a very vital role, and what we do is we provide you courses to bridge that gap. By getting certified in these skills which are required directly by the industry, you enhance your knowledge, you enhance your skill set, and you become zero-day productive. So that's what we do at NASCOM. So filling up the digital gap, filling up the digital skill gap, and providing you enough opportunities to get employable and come out as a skilled and certified workforce. So today we are here because there's a platform that exists, which is FutureSkillsPrime.in, and that's NASCOM's platform. Ministry of Electronics and Information Technology has funded this. The process to enroll for this and register on this platform is really simple, and I'm sure you would have gone for that already. That's why you are here. So you registered on the platform. You selected a few technologies as a part of your area of interest, and currently you're taking one of the foundation courses, which is this step, taking the foundation courses. Later on, once you do this, once you've completed this course and the certification, you can go ahead and take up additional courses which fall in the category of deep skilling. As a part of this course, you also earn digital skill badges, which are directly given by Google Cloud, and that you can post on your LinkedIn and professional profile. Now, as a platform, we have had a huge success so far. The journey so far is that we have close to 1.6 million users already signed up on the platform. And we have 92 lakh plus digital fluency batches already issued, 6.61 lakh plus course enrollments and completions. And majority of them, I would not say majority, but 36% of them have been the women who have shown their interest in this platform and have taken up a lot of courses. So especially what we do is we target the communities which are under recognized, like women back to workforce. So that's all that is something also we target during these programs that we offer. Now, everyone has this question in their mind that what do we do after we get certified? What's next? So that is where NASCOM again plays an important role. So we have launched a portal called Talent Connect portal. In this portal, what we do is, first of all, there are certain prerequisites for you to be able to apply for jobs within this portal. This portal has various jobs which are posted directly by the industry, and the people who are really in who have really come up as a scholar and who have completed this course, the courses properly, have taken the NASCOM certification, get directly signed up on this portal and can apply for jobs straight away. Now, this is not a generic portal just like you would have heard as Naukri.com or Indeed.com. This portal is not general like those platforms where everyone can get in. This is specific to people who have taken courses on Future Skills Prime and have got SSC NASCOM certified as well. So the main objective is to cut short the number of people who are really interested to take the certifications and who are really interested to apply for jobs. And be it specific to the industry, we have got all sorts of jobs available on this. Even internship opportunities are also available on this platform, which is NASCOM Talent Connect portal. Additionally, from time to time, we do conduct job fairs and career fairs. So depending upon the requirement, which is from a specific industry and at a specific location, we do in-person job fairs as well. And of course, you can also participate in those. So you can see on your screen, this is what NASSCOM has done so far across the country, and there are a few recent additions which is not there in this slide. But what we do is we try to make this learning journey a little bit easier for you by giving you courses which are accredited and embedded in your curriculum. So when we say embedded in your curriculum, you don't have to do these courses separately. While the skill ministry of your state would make it useful for you or make it mandatory for you to do these courses, and embedding that in your curriculum will give you less time, less extra time to be spared on these courses, but you can do it within your learning ecosystem in your college or university. Now, we have definitely created a good impact across the country, and you can see on your screen a lot of reviews posted by various diversified people from various diversified, regions and various diversified jobs that they do, or various diversified fields that they come from. There are students, there are working professionals as well who have given their reviews, and they have definitely benefited out of the learning and certification ecosystem that we have developed. So that's it from my end. I will now hand over to Jitendra. So Jitendra, let me give a quick introduction about Jitendra. First of all, let me stop presenting. Okay. Okay, so Jitendra is a seasoned IT professional with 20 plus years of experience working with the top-notch product and services organizations. Currently, he is a Google Cloud technical trainer specializing in cloud infrastructure and security. And that's why we are addressing the important topic, modernize and secure infrastructure in Google Cloud today. So Jitendra's expertise has helped him successfully train over 1,500 professionals from 100 plus organizations across the continents. With a proven track record in pre-sales, GTM, and strategy, his experience includes building innovative solutions and crafting compelling cloud strategies. So we welcome you, Jitendra. I would now hand over to you to take this forward. Thank you.
Yeah, hi, thank you so much, Akash. I hope I'm audible.
Yes, loud and clear.
Fantastic. So let me start sharing my screen now. Okay, fantastic. So thank you so much, Akash, for that kind introduction. And everybody, a very, very warm welcome. I'm so happy to be here and so happy to share whatever little I know. Akash has already introduced me, so I will not get into details. But my LinkedIn link is here on the screen. Just in case if you would like to connect with me, feel free, please send out a connection request. I would love to connect with you, right? And today we are going to spend next 90 minutes learning about, so these are like three pieces of this whole puzzle that we are trying to solve today. The part one of the puzzle is how do you build a modern web application, right? And then second part to that is basically how do you secure that, and how do you secure the underlying infrastructure. So the focus here is Google Cloud, and therefore we will see that when you bring your application into Google Cloud, what tools and technologies Google Cloud gives you to secure those infrastructure component as well as application components, right? This is the agenda that we will be covering today. We will be talking about. We will begin with data management. Then I will be also giving you certain demos in between, right? So as to make sure that you understand how it looks like. What do you do? How do you go and actually play out with those services? We will continue to talk about modern web applications and how do you secure them using Google Cloud, right? And finally, we will also want to have and make sure that all your questions gets answered regarding all the presentation that I will do today, right? All the presentation and all the technical demos that I will do today. So please feel free to put your questions in the Q&A section. something that Akash was referring to earlier, right? So that we will take a logical break in between and then quickly look at all the questions which are there, and I will try to address all of them in a reasonable time, right? Okay. So now imagine when you start building a web application, right? Or for that matter, any modern web application or mobile application or a game, or maybe it is a serious enterprise application, could be CRM systems equivalent, could be your, anything otherwise, right? What do you look there? You basically are building a platform using maybe say Java J2E architecture, or maybe Python Django application, maybe it's a Go application, right? Maybe it's a microservices based distributed architecture that you have decided to build for your application, right? So one part of your application is the application code that you are writing, Python, Java, Go, Node, PHP, whatever, right? And then the other part of the application is the databases that you will need to pick up, right? So in this section, we are going to focus on, hey, what kind of database services would you require, right? And what is it that Google offers? Because your modern web and mobile applications will also need a modern database solution, right? Which can handle what? Your scalability, performance, security, reliability, right? All these kinds of requirements. Okay. So in this platform, let us see what kind of databases options do we have. So now when you look here from left to right, these are all the database options that we see here. Now, what do you see here, right? I'm sure if you are in college or if you are a working professional, you must have come across these different database types now, right? There is a database category which is a typical relational RDBMS or relational database services, right? So what is it that Google provides as a typical relational database service? So you see in the two green color boxes here, the relational database services, what Google provides is one platform which is called as Cloud SQL, and then MySQL, PostgreSQL, and SQL Server. These are the databases which are supported part of Cloud SQL. We will get into all the details here, right? Don't worry. But just to give you a broad picture, a big picture of all the database services that we have, right? The other database service, which is kind of Google proprietary, right? And it is very, very powerful database, which is Cloud Spanner. So when it comes to a relational, typical relational database that you are looking for, you can pick up one of these two. Look at the next box, which is NoSQL. I'm sure some of you have come from or have worked in open source ecosystem. If you have come across a document database, one example like MongoDB, right? A very equivalent of MongoDB, a typical standard document database, which is a NoSQL database. Google provides is Firestore, right? Now, if I compare another open source database like Cassandra, right? Very equivalent of Cassandra as a NoSQL database in Google Cloud. Now, I'm not saying that this is MongoDB. This is Google database, right? I'm just giving you a comparison for you to start making up your mind. Hey, I know about MongoDB, right? It is equivalent of MongoDB. It could be far better than MongoDB or may not be, right? So it is for you to compare and for you to look at feature functionality and capability, right? But for you to start thinking, start making up your mind that yes, I have heard of Cassandra, which is a open source, which is a very popular NoSQL database in open source world. The equivalent of that in Google Cloud is Cloud Bigtable, right? So these are two NoSQL database choices that we have got in Google Cloud Platform, right? Now, hey, I'm building a data warehousing solution typically for my OLAP kind of workloads, online analytical processing, right? Now, for those situations, Google provides us a very, very popular and extremely powerful service, which is called as BigQuery, right? Go right onto that. If you are looking to store your unstructured data, right, where you do not have a typical standard columnar structure, a row and column structure, a key value pair structure, but maybe that you treat your files and objects as a lump of bits and bytes. It's all unstructured data. So some examples of unstructured data: your videos, your images, your text files, your backup copies. These are all unstructured data, right? So Google gives us a very relevant service for the same, which is object storage service here, and that is called as cloud storage, or GCS, Google Cloud Storage Service, right? That's basically for unstructured data. Now, if you have any experience dealing with on-prem database services where you also had, say, block storage or file storage coming from likes of NetApps and EMCs or Hitachi and IBM, right? Similarly, in Google Cloud, we have block storage, which is nothing but persistent disks. And we have different types of persistent disks, both spinning mechanical standard disks as well as SSDs, which is solid state device machines, right? These are your block storage devices, persistent disks, which are available for you to store your application specific data, right? As well, we have support for file store, which is basically a a NAS service, right? On the extreme left, when you see, right, if you have used the Redis or Memcache for basically caching services for your application, for you to improve the performance of your application, you might want to consider in-memory database in Google Cloud, which is equivalent of Redis and Memcache, right? So now what do you see here, right? I mean, as a solutions architect and as an application developer looking at modern web applications, right, you also need cloud native database services, and these are some of the choices that Google gives us. And you can, based on feature functionality capability, based on different characteristics that we will learn in next few slides that we will learn, right, you can pick up one or the other. Okay, now let us get into more details. For example, if I want to pick up cloud storage as a service, what are the use cases, right? So cloud storage, as I said, is basically for your unstructured data, right? So it could be a very good place for you to store all your images and videos and the backup copies, etc. Imagine you have a website which is example.com, right? Through that website, you serve lot of images and video content. All of that images and video content could actually be hosted inside GCS bucket and then referenced as a unique URL for every object in your HTML page, right? And your images and videos, etc., would be coming directly from your cloud storage bucket here, right? So this is your first very important use case you could think about. Now, hey, you could be doing data center migration or data center exit. Imagine you were in on-prem data center. Now you want to move to Google Cloud, right? You might have a lot of legacy data, petabyte size, tons and tons of data that you want to immediately move. Even before you could decide what will you do with that data, how will you process that data, whether you will need to massage that data and transform that data, this could be a place to simply dump all your legacy data before you build a data pipeline to basically transform your data and then choose another appropriate database choice here, right? So it could be a good place for your all the data, including legacy data, to sit here, and therefore it could help you to build analytics services running, right, where data is backed up by Google Cloud Storage buckets, right? And as well, of course, if you have any running workloads either in Google Cloud or outside Google Cloud, for business continuity, what do you need to do? You have to take backups, right? I mean, if something goes wrong, you need to be able to restore your services using those backups. And where do you store those backup copies, etc.? GCS bucket could be the place for you to store those backup copies and archival copies, right? So these are at the very high level some of the use cases you could think about when it comes to Google Cloud Storage bucket, right? Now, generally speaking, right, I mean, for the users, when it comes to databases, what are their priorities? And this is something that Google shares as a priority with you, right? You could be thinking about migrating existing databases to the cloud. And as I said in previous slide, GCS bucket could be the place where you could bring all your data and then decide to build a pipeline and transform your data before you basically move the data into the target database service that you might have chosen, which could be more appropriate for the application, for the service that you have picked up, right? Similarly, if you are innovating, building or rebuilding something like a mobile or a web app, right, you need to store all of this like a game state. If you are building a game, right, if your application is backed by tons of images and video content, GCS bucket is a fantastic place for you to store all of that, right? And as I have been saying, this is primarily for your unstructured data, right? So compare structured data with unstructured data, right? You have to keep in mind that when it comes to structured data, you are basically looking at rows and columns, right? So if you have dealt with typical standard relational database services, you have dealt with structured data there, right? You have created a table, and then within that table you have rows and columns, and there you go and start storing your data. But when I am talking about GCS bucket, I am basically looking at unstructured data, which is this one here, right? It is unstructured data that I'm looking here. Now, what are the examples of unstructured data, right? Transactions, backup copies, text files, images, videos, your email backups, your chat backups, all of this is unstructured data, right? They are not stored inside our rows and columns, but they are stored as an object, right? As a lump of bits and bytes. So what is cloud storage? Let me slightly move my laptop so I can, yeah, this is better. Sorry. Okay, so what is cloud storage here, right? It is, as I said, it is an object storage service. Now, for me as an application developer, I worry about availability. I worry about how do I access that, right? I need some of those key capabilities and features. For example, for a developer, the important aspect is how do I start accessing GCS bucket, right? And programmatically. So I do have API calls, and these APIs are very simple to access. There is a beautiful API documentation which is available, right? So for you to read, to write, to create an object, to upload an object, to delete an object, or to set other rules in GCS bucket, like any other Google service, you have an API call to make here, right? You can do the same. It is highly reliable, and so you have ability to create a regional bucket in GCS, right? When I say regional bucket, it is basically that your data would be replicated across multiple zones in a region. In Google Cloud, region is a metropolitan area, right? When you start configuring your services, when you start using, say, Google Cloud Storage bucket, you decide where my data will be hosted, right? So I pick up a region. If I'm building an application which is going to serve Indian customers, right? Now I might decide that maybe Mumbai and Delhi, because these are the two regions which are available in Google Cloud Platform, this is where I will store my data, right? So I could build a GCS bucket which is either regional or multi-regional. When I create a multi-regional bucket, it maintains multiple copies across those regions that I have chosen. And therefore, it gives me very high availability. 99.95% of contractually guaranteed availability number is available to us, right? It means your cloud storage bucket will be available at least for this much amount of time in a year, right? So understand, it is a very good number, very high number, and that helps, that definitely helps us a lot, right? But because it is a multi-regional bucket, even if one region goes away, no problem, my data will be available in another region. So my application will continue to access my data from the other region, right? So therefore, making those technical decisions will help you to improve these availability aspects, right? And this is coming from Google Cloud Storage bucket. It is very cost effective. The standard bucket costs you 2 cents per GB per month. 2 cent when I say 2 USD cents, right? And when you are using actually the cold storage, which is another storage class that we will touch upon later, it could be as cheap as this is USD dollar we are talking about, 0.0012 USD dollar per GB per month. Extremely cheap when you actually put a calculator and then see that, okay, how much totally it will cost me to have say 100 GB of data in Google Cloud. It is cheap actually, right? Now, Google takes security extremely seriously, right? Google does security at every component, at every layer, in every aspect, security is built in, right? So in that situation, when it comes to encryption, which is one part of security that Google does, Google actually gives us multiple ways to secure our data, right? How can we apply data encryption there? Right? So one is you leave everything to Google and you will see that Google manages all the aspects of encryption for us, right? Which is default encryption, Google managed encryption. But going forward in few more slides, we will see Google also talks about 3 other ways to encrypt your data, right? Which is CMAC, as we call customer managed encryption keys. So you could decide I will use my own encryption keys to encrypt my data. So nobody has access to those keys and nobody can read my data, right? Making your data as secure as possible. And then another is CSEK, customer supplied encryption keys, and as well as there are third party encryption keys. Basically, there are encryption clouds which are available, like from likes of say Thales, Photonics, Ionic, which is called as EKM, External Key Manager, right? So without getting into more details, I just want to highlight here that you have ability to meet your security requirements, compliance requirements, and then improve your security posture by selecting different security options, including different encryption options which are available for us and which includes cloud storage also, right? So these are kind of capabilities which are available with Google Cloud Storage bucket, right? And these are different storage classes that we have got, right? So go with standard storage, nearline, cold line, and archive, right? These are 4 standard these are 4 storage classes that we have. Now look here, when I say minimum duration, it is basically.
I'm sorry to interrupt, Jitendra. I think we were discussing about the transaction. So there's a question on the chat. Nitesh Tiwari is asking that how the transaction can be a type of unstructured data.
Transaction. See, transaction will not be unstructured data, but when you back up your transaction, right? I'm talking about backup copies here. For transaction, you might actually need a standard typical relational database. So you might actually use Cloud SQL and you could actually configure your standard typical relational database, right? Because you need asset compliance, you need other capabilities that are very typical relational database needs. So OLTP kind of workloads, you need a typical standard relational database. But when you are taking a backup, imagine you have MySQL, which is running in Cloud SQL. Now, in Cloud SQL, you might want to export out your data backup copy, which could be a CSV file, or it could be a dump, a MySQL dump, right? That CSV file or the SQL dump could be put into cloud storage bucket, right? Yeah, I think he replied that. Akash, I think he has got that answer. Anything else, Akash, relevant here?
No, I think you can proceed. Thank you.
Okay, fantastic. But good question. Thank you so much for paying all the attention and asking relevant questions. Thank you so much. Okay, let's move on. So basically what I was talking about is you have 4 storage classes, standard, nearline, cold line, and archive, right? What is the difference? Basically, how are you charged here is the difference, right? So this is the minimum duration in standard storage class. In standard storage tier, you are charged for only the amount of time that you store your data there. So imagine you upload 2 images inside cloud storage bucket by creating a bucket of type standard storage class, right? If you keep there for 10 days, you will be charged only for 10 days. There is no minimum duration, right? But then the charges are little higher, which is 2 cents per GB per month, right? But when it comes to say cold line or archive, it is gradually very like 1/5 and 1/10 of the charges, right? Archive is nearly one by 20th of what you pay for standard storage. But then there you are paying for minimum amount of duration. So when you upload a storage object, you will be charged for minimum 365 days, right? So why should you use archive storage? Imagine, for you to meet your compliance requirements, you have to keep backup copies of all your financial data, right? Now you want to store that at very cheap cost, at extremely low cost, okay? And as well, you have no need of accessing that data too frequently, right? So therefore might be that you will save a lot of money when you put that into archive storage. Why? Because you know that in India, for example, we need to maintain our financial records for minimum 7 years, right? So now here, for me to do that, I can simply go and put that in archive storage class, which would be nearly 1 by 20th. Of course, please check for the exact pricing, check the GCS pricing sheet which is available online, right? But this is like 1 by 20th of price of standard storage. This is, if this is 2 cents per GB per month, this is 0.0013 cents per GB per month, right? Nearly so, right? So charges are lower, but you pay for the minimum duration, right? Now, when it comes to availability, as I was explaining, these are all the availability numbers which are contractual guarantees that Google gives us, that, hey, I will give you this contractual guarantee. So based on my technical and business requirements, I could decide whether to create a multi-regional bucket or a dual regional bucket or a single regional bucket, because charges will definitely vary there, right? Multi-regional is slightly expensive versus the say regional, right? So based on my availability requirement, I could decide one or the other. Now, I have explained these use cases earlier, but some of the examples are also listed here, like backup copies, like if you have to maintain your data or the application backups to meet your compliance needs or to meet your HA and DR needs, etc. Right? All of these use cases could be the ones which could be in those situations. You could basically use Google Cloud Storage Bucket. Okay. One more very important use case I have not touched upon, and that you can think about. Hey, imagine I'm a student and I'm running my own blog, right? Now, if I go and write that blog in WordPress, etc., I pay for a lot of components there, and it becomes quite heavy, right? In a sense that my WordPress needs MySQL, it also needs a server. It's a server side application that is being run here. But imagine if you could build your blog websites in complete static, in complete. I'm sorry. Yeah, in a complete static form, right? In a way that it has only HTML, CSS, and JavaScript, right? There is no server side component, and you know that every time you publish a new blog, it is all HTML pages that you have got along with certain CSS and JavaScript. Now, all of that, your website standard, your static websites could be hosted out of GCS bucket, right? So for me, this becomes like pretty cheap way or pretty low cost mechanism to host my blogs, to host my static websites, etc. Right? That is something I could think about here. Okay, now certain things, characteristics to remember. When you create a bucket, it has to be globally unique. You will be asked to select a location, and all these storage classes, nearline, cold line, archive, or standard, I will have a choice to select, okay, which storage class. And then not everybody should have access to my buckets, right? So now for access management, Google gives you what we call as IAM, identity and access management service. Okay, using IAM, you could decide whom to give access to these buckets for administration purpose. Right now, imagine there is an image that you want to publish on your website. That is something you might want to make it as a public. Right, so your objects could be of two type, public or private. Right, as well for administration purpose, you could use IAM or ECL lists there. Okay, you can also do version control. So you could have files with multiple versions maintained here. You can list those versions, you can delete, you can retrieve previous version, you can make previous version as the latest version, etc. Right? That is something that is available for us. Okay. Now this last one is very interesting. Imagine I told you just now that hey, in India, we have to maintain our financial records for minimum 7 years. Right now, we know that unless there is a IT department query which is coming to us, we don't need to actually access any of those records. So what do I want to do? Hey, after 7 years have passed, I want to immediately go and delete them, because I want to stop paying for storage charges that I'm incurring when I'm keeping that data inside the GCS bucket. So you can configure lifecycle rules such as that, based on date of creation, right, based on date of creation, delete this after after these many days, or these many years, or after this particular date. You have multiple ways to define those life cycle rules that could become actually very useful for us. Right, so who uses this? Of course, Google also uses Google Cloud Storage as underlying service for many of these capabilities, like Doc and Gmail, the enterprise Gmail that Google provides us. Right, yeah, in the underlying infrastructure, it is Google Cloud Storage bucket, which is in turn is used here. Okay, so this was about a object storage service. Let us talk about some of the SQL based or relational database options that we have got. Right, so two choices for your OLTP kind of workloads: online transaction processing, as Nitesh was asking earlier. Right, hey, if it is transaction that I'm dealing with, right, then what do I need? I need a very standard typical relational database service that I have got. Right, and two choices we have got for your OLTP workload: Cloud SQL and Cloud Spanner. Cloud SQL gives you all of these capabilities. It supports MySQL, Postgre, and SQL Server. Right, of course, you have ability to take configure automatic backups. The incremental backups will be taken on the timeline that you define there. It does automatic replication. It can do vertical scaling for you. Right, it means you can continue to add. One is you can configure this to add additional storage by itself as and when it is running into storage, exhausting the storage capacity issues. Right, you have horizontal scaling also available. It means you could have one primary database instance and then read replicas which are created in other regions. Right, so basically both HA and DR kind of situations are managed here, simply because you could have a HA instance which is created in one zone and primary instance in another zone. So if one zone fails, no problem, HA takes over. Right, your HA instance takes over. So distributed, it is distributed in a region, but then read replicas are sitting outside the region. So if this whole region goes away for some reason, right, connectivity or power loss or any other failure which could happen, then we could actually promote our read replica to become the primary instance there. Right, so this is also possible. Cloud SQL is one choice. Then Cloud Spanner is another choice here. Right, Cloud Spanner is Google proprietary database. Right, what it gives you a architecture where you create multiple nodes. Right, and the beautiful thing with Cloud Spanner is it is horizontally distributed database. What it means is you can create multiple nodes even in multiple continents. Right, so today Google gives you 40 regions. Right, in India, two regions, Mumbai and Delhi. Okay, and then across the world, for example, Singapore is one region, Tokyo is one region, Jakarta is one region, the two regions in Australia. There are a dozen plus regions in Europe, a dozen plus regions in Americas, both South and North, and then there are 2 regions in Middle East, right? So you could decide that, hey, my application is globally deployed application, right? And I need a database which is running its nodes across multiple continents and geographies, right? And Cloud Spanner gives you that capability out of the box. You can go and configure nodes in multiple geographies, right? And that gives you a horizontally distributed database. And this is a typical standard relational database. It gives you asset compliance. It gives you strong global consistency, right? That's the beauty. And then how do you access this? So it has support for standard NCSQL 2011, right? So it has a lot of ORM solutions also available. APIs are also available. So multiple mechanisms for you to integrate your application with Cloud Spanner for you to be able to read and write. Okay. Now coming to Cloud SQL, it is fully managed. What it means is you don't have to do any patch management there. You don't have to apply security patches, etc., right? Once you have configured backups, it continues to take backups, etc., right? You don't have to worry about that. Now the limitation is it's a vertically scalable architecture. What it means is your primary instance is limited to 96 vCPUs, right? And 624 GB of RAM. Okay, so that is the primary limitation. Now, for most generic use cases, that in fact is good enough. But sometimes, if it is not good enough, then you go and choose Cloud Spanner, because with Cloud Spanner there is no such limitation. That it is because this solution, which is Cloud SQL, is vertically scalable. Cloud Spanner is horizontally scalable. You can continue to add more number of nodes, right? Highly reliable. You can configure backups, you can configure read replicas, etc. And all the data at rest is always encrypted in Google Cloud. So very similar to Cloud Storage Bucket we spoke about earlier. In Cloud SQL or in Spanner or all other databases that we will talk about, all the data is always encrypted. Okay, what you do is you decide how do you want that encryption to happen. If you leave that up to Google for everything, then Google does the default encryption, Google manages the encryption keys, etc. But you have ability to decide, no, I will tell you how to manage my encryption, what size of keys to use, what algorithms to use, how frequently do you rotate my keys, etc., right? So that encryption, how that encryption happens is up to us. Okay, now in terms of compatibility, it is compatible with your open source NCSQL. All the tools like Workbench, Todd, etc., all of those tools are compatible here, right? So you can make use of all of them. Now when it comes to Spanner, remember with Cloud SQL my limitation was 96 vCPUs and 624 GB of RAM. Cloud Spanner has no such limitations, right? Cloud Spanner is horizontally scalable. What it means is I could have hundreds of nodes of database running in multiple continents and in multiple regions in Google Cloud Platform. And my application could be a globally deployed application, right? And it will see consistent behavior across the world, wherever the application is accessing data, simply because my data is replicated across multiple nodes, across multiple continents, right? So it is highly scalable solution for your superpower applications that you might have. Now, it is a very standard, typical relational database. So yes, strong consistency, ACID compliance, relational schemas are there, right? All of that is there. Something that you attach to as a typical standard behavior to a relational database is all available with Cloud Spanner here, right? Now, how does that work? Basically, so in this diagram, what you see is zone 1, zone 2, zone 3, right? Now, these zones could all be in different regions or in same region, right? So zone 1 could be region in Tokyo, zone 2 could be a region in Mumbai, which is another region in Google Cloud, zone 3 could be another region, say in Europe or in US. Absolutely okay. What you do is write happens in, say, zone 2, it will be synchronously replicated across zone 1 and zone 3, right? There are lots of white papers. Now if you are a little more technical, you understand the difficulty of how this happens, right? I would advise that you search for something called as Paxos algorithms. Okay, what Google has done is Google has done a lot of research, and Google has published lots of white paper in terms of how we are achieving this, right? So if you go how reads and writes happen in Cloud Spanner, right? The first 5 entries in your Google search, you will find Paxos algorithm, right? And then you will realize that, okay, that white paper basically explains that how is it going to do the same. Okay, so this is something that you could take as an homework for you to learn how a distributed relational database is achieving strong consistency, right? Something which is unheard of. Okay, now when it comes to NoSQL databases, we have Firestore and we have Bigtable, right? Now Firestore is a typical document database, right? So when you have semi-structured data where you need to store your data in key value pair, name colon Jitendra Jain, organization colon Google, right? This is key value pair. There is no schema here. There is no tabular format, rows and columns here. It is schema less, right? So it helps for certain types of use cases. For example, you are building a social media application and you need to store your user profile, or you are building a game and you need to store game state, right? Firestore could be the place where you store your game state. Okay, this is a document database. It is available with low latency, and again, Firestore gives you 5 nines of guaranteed availability, and that is also available with Spanner. Something that I missed to tell you, but remember, with Spanner, what you get is 99.999% of guaranteed availability. Very high number. Similar guaranteed availability is available with Firestore also. 5 nines of guaranteed availability, right? It scales automatically. It is serverless. So unlike MySQL or unlike Spanner, where you had to configure the database instance, right? However minimal that work was, but you had to select how many CPUs, how much memory, how the node will look like, where the node will go and sit. Firestore is completely serverless. You don't configure anything there as the underlying infrastructure. What you do is you create a collection. Within that collection, you create a document, and then within that document, you simply start getting your data into that document by making API calls, right? So for your mobile apps and for your games and for your modern web applications, Firestore as a document database could be a fantastic solution, right? User profile, product catalog, recording transactions, mobile games, all of these are some of the use cases that you could think about here, right? Now Bigtable. So I would say Bigtable is not serverless, but Bigtable is massively scalable. Right? I mean, you would not come across a database which can have millions of random reads and writes on a per minute basis without any performance issues. Something that Bigtable gives us, right? So imagine a situation where all the financial institutions where they need to do millions of transactions in a minute, or imagine very large organization like NASCOM. Imagine if NASCOM does tomorrow a big bang event, and then there could be lakhs and lakhs of people who are interacting with a social game that NASCOM launches tomorrow. Right now, in the real time, maybe NASCOM says that, hey, we will give certain awards and rewards to those people who are interacting with our app that we have launched for this social media event that we are doing today. Right now, in real time, there could be millions and millions of people who are doing clicks and interacting with that NASCOM app, right? And backend side, you need a database which can actually do millions of reads and writes per minute without performance tapering out, without any scalability issues, etc., etc. Bigtable is the one database that will definitely give you that edge here, right? So Bigtable is very fast, highly performant, very low latency, right? It gives you single digit millisecond latency. So typically, when your application reads and do a RTT, which is round trip time to the database, right? Most of my application developer friends worry about, hey, how long it takes for my application to read and write to the databases, right? Bigtable is highly performant there, right? So another use case I want to talk about is, this is also fantastic when you are moving your Hadoop workloads, say from on-prem or any other public cloud into Google Cloud. And we know that for Hadoop, HBase is the underlying data storage solution, right? And your application code, which is Java or R or Python, right? When you are writing that application in Hadoop, right? How do you access HBase? So it is basically HBase APIs which are given for you to read and write from the HBase storage layer, right? HDFS basically, which is Hadoop file system. Now, when you replace Hadoop file system with Bigtable, you don't have to make any changes on the application side. And why so? Simply because Cloud Bigtable is HBase API compatible. You can continue to you keep the same piece of code, same HBase API will be able to now read and write from Bigtable, replacing your HDFS there, right? So Bigtable is again very capable, performant service for certain use cases when it comes to databases. And of course, right, I mean, when it comes to Google Analytics, when it comes to Google Map, in fact, for Google search, right, Cloud Bigtable in a form is used in Google also, right? I mean, this is also our go-to solution within Google Cloud, within Google, right? So you can understand how scalable it is. Okay, so this diagram could be one way for you to select one or the other service. So the question is, hey, when I have to select one or the other database service, question to ask is my data structured data or is it unstructured data? Right? Or think about this, structured data, semi-structured data, or unstructured data. So what is structured data? Typical transactions which needs to go and sit in a table, right? Rows and columns. That is your structured data, right? Semi-structured, which could be your key value pair. Hey, I need a document database. I need a graph database. I need a columnar database. Some kind of NoSQL database is something that I am looking for. Or this is unstructured data. It means, what is it? It is images, it is videos, it is backup copies, text files, etc., etc. Anything and everything as a bits and bytes, right? That's my unstructured data. Okay, so yes, if it is unstructured data, go and pick up cloud storage, right? If it is semi-structured, you could basically look at data store, which is name of previous version of Firestore. So it could be Firestore or it could be Bigtable based on these other choices, right? Low latency, high latency. See, again, because why we choose one over the other, we also do cost benefit analysis here, right? We don't want to buy Mercedes for simply transporting people if there is no arithmetics of dollars involved there, right? So you do cost benefit analysis also there and select that, hey, if I have two competing services, relational database, yes, I do have Spanner, I do also have Cloud SQL, which one do I pick up, right? So do cost benefit analysis. If you do not need those capabilities that Spanner gives you, you are happy with what Cloud SQL gives, maybe you will save a lot of money by choosing Cloud SQL there, right? So the decision could be both technical parameters and as well as business and cost parameters, right? So this is the way you will choose one of one of the database choices here, right? So when we are building a modern web application, we need a modern database service, right? And these are some of the database services that we have got with Google Cloud Platform. Now for your application itself, right? I mean, if it is a distributed architecture, imagine when a fintech, imagine Paytm, right? All of us use Paytm, all of us use GPay. Now, what does GPay do when you actually make a transaction to your store, right? The grocery store where you are buying a pack of bread, right? He says, hey, scan your code, barcode here, right? Or scan that QR code. What happens there on your mobile phone? How many parties are involved there? One is Google, because Google is giving you GPay, right? One is your bank, because you are making a transaction from the bank to somebody else's bank, right? And that somebody else may be on Paytm, somebody else may be on PayU or something else. Remember, right? So it is actually multiple applications and multiple organizations who are dealing with each other here to give you this seamless transaction which is happening, right? So how is that happening? Hey, as a ICICI bank, maybe my implementation will continue to change. It may be as complex as whatever it is, but nobody outside. So if ICICI bank has certain capabilities that it wants to expose to a fintech, maybe Paytm, right? Paytm becomes its user here, right? And then what Paytm is doing is it is making API call to ICICI bank. So this has to be a standard, simple, versioned interface for your application to be exposed to other third parties. And similarly, those third parties consume your application by consuming your APIs. So when you think about, hey, I am building a service that could be programmatically invoked by other services, by other applications, how do I do that? I need to, of course, give them APIs, application programming interfaces, right? So what API does is API basically abstracts out all the complexities, all the implementation details, and what they give you is basically a very much versioned interface for the third party application or a mobile device to make an API call, right? So what is it Google gives us? One is, hey, what do we need? We need interface definition, which has to be published. We need the ability to manage and scale. Imagine I could have one API call. Now, every month, I believe our NPCI, which is national, the body who manages this whole power, this whole payment infrastructure, right? I mean, they published how many billion transactions happened, right? I mean, I think we have crossed very huge number, some trillion rupee number is something we have crossed, which is humongous. It means at every given point in time, there are millions of API requests which are going and coming in, right? So you need a solution which can scale, right? It could be your application is accessed, and if it becomes popular, it is accessed by millions and millions of services and transactions are happening, right? Hey, not everybody can make an API call. Are you allowed to make that API call, right? Are you a valid user so that you can make that payment from your bank? Not everybody should be allowed to make a payment from your bank. Now, who is ensuring that? When you make an API call, you are authenticating yourself as a valid user, as the owner of that bank account that you are using to make that payment. Right now, for you, for the service providers, including Paytm and GPay and NPCI, etc., etc., they need ability to be able to monitor, right? Is everything going well, right? You need logging and monitoring services for each of these parties. So we need something around APIs which can do all of this for us, right? So we need so we have two solutions provided by Google. One is called as Cloud Endpoint, and another service is called as APG. Now, what are they? So basically, these are API gateway solutions, right? What it means is, hey, I will focus on writing very beautiful application which focuses on business logic alone. And we know that these are very standard capabilities that everybody needs. Can somebody else gives me these capabilities, all these four capabilities that we are talking about? Interface definition to authentication, authorization to logging, monitoring to scalability, etc. Right? Who can give this to us? Cloud Endpoint as the API gateway gives us all of this out of the box. So when I write my Java application, I focus on the business logic. I don't focus on actually building API the interface which can scale or which can give me those authentication authorization capability. Why? Because that is given by Cloud Endpoint for me, right? So what cloud endpoint gives me? Protection, speed, monitoring and logging, and integration capabilities for other services to talk to my API gateways here, right? So a lot of details are here. I will not get into those details because this itself could become a complete one-day topic for us to get into, right? So I will leave these details for you. Yeah, hi.
Yeah, so we have a question parked in for the very long time now. So Deepak is asking whether Google provides private cloud setup facility where an organization will decide region and zones.
Yeah, so Akash, you said Deepak, right?
Yes, it is Deepak Kumar.
Okay, yeah, thanks, Deepak. So yeah, one is understand it is a public cloud that Google has built, right? But then very soon, I think it is already there, the information is already there in public domain. What Google is coming out with is something called as GDCH, right? Google, let me open that. I think it's a very interesting topic. We are still working on that on Google side. And just a minute, I'm just trying to escape. And yeah, so So this is a service which will be actually Google distributed cloud hosted, right? This is a service which is there available right now, but it is now kind of becoming better and better, right? This is something that you would be able to run in your own data center, which is extension of Google Cloud, right? Which is Google distributed cloud hosted. So if you like to use all the services which are hosted by Google Cloud in Google data center, then it is Google public cloud that you are dealing with, right? And this is the service which is Google distributed cloud hosted, GDCH as we call it, right? I mean, this is something where you will run Google Cloud, but in your data center, in your own premise data center, and you will be able to manage. Now, this is not for every customer. This is basically for those customers who actually are worried about, say, sovereign cloud. For example, Government of India, the Department of Defense, and certain other organizations, they need a air gapped solution, right, where nobody has any access to things, but they still need Google services, where Google has done a lot of innovation in terms of how these different databases and data warehousing solutions and all these machine learning algorithms are made available. They all will be made available via Google distributed cloud hosted, right? So for nearly everybody, the public service of Google Cloud is what they would be looking at. But say for sovereignty, for data security, you are a very large financial institution, and in such situations, this could actually become useful for you, right? Yes. So if you have those requirements, please get in touch with us. We would be happy to introduce you to the right people to take it further. Deepak, does that answer your question? I don't know, Akash, where you are finding that, because I have opened up chat window here and I did not see any such question. Maybe it is Q&A I should open.
Yeah, so it was under the Q&A and I've dismissed it because it was answered live.
Okay. So
Yeah,
I will look at Q&A now. Okay,
yeah.
fantastic. So Akash, any other open questions now?
No, no, we're good.
Fantastic. Thank you so much. Okay, so this is what we were talking about until now, that hey, for our modern web applications, we need API gateways. And what Google gives us is two solutions: Cloud Endpoint, which is one. And then what Cloud Endpoint does is Cloud Endpoint lets your backend services running in any of these Google products and services. For example, for your compute needs, you could run your applications either in App Engine or in GKE or in GCE, which is Google Compute Engine. There are many other options like Cloud Function, like Cloud Run, which are not listed here. This is not exhaustive list. But as long as your backend service is running inside Google Cloud Platform, right, you could use Cloud Endpoint to expose those capabilities as an API, right, via the API gateway, which is your Cloud Endpoint here, right? And then the other service that we have is is basically APG. Now the difference in APG and cloud endpoint is cloud endpoint supports only the backend services running in Google Cloud. But what APG supports here is you could be going with multi-cloud or hybrid cloud architecture, so that your backend services could be running maybe couple of them in Google Cloud, but few of them in AWS, few of them in Azure, and maybe some of them in your on-prem data center. No problem at all. Behind APG API gateway, everything can sit, and APG can give one single interface to your end consumers for making API calls. Right? APG also is very capable, very powerful for few other things, such as APG gives you API monetization. For example, every time you make an API call, I will deduct 2 rupees for that API call. Right? Those capabilities are there with APG, but not with cloud endpoint. Right? So two solutions are there, and each of them serve different use cases. So when it comes to selecting a API gateway solution for your modern web application, you have to basically dig deep and decide whether cloud endpoint would be good enough for me, or whether APG is something that I would like to look at. Right? It's a API gateway solution. As I said, it could be your legacy app, or it could be any service running anywhere for that matter. Right? This is running in Google Cloud. The blue box that you see is running in Google Cloud. And this is running outside Google Cloud. No problem. APG could have all of these backend services running and could expose your API calls. So your partner, consumer, employees app, or other microservices, or your mobile endpoints and those devices, they all could make API call to access your services here. Right? Now, so this was the second part of this whole equation that we have discussed. The third part of this whole equation is, hey, sometimes you also might need to build what we call as data pipelines. Right? Now, what are these data pipelines? Hey, I might be getting data from disparate sources of different data types. Imagine I have a billing application. Right? Now, this billing application, imagine you are Star Bazaar or you are DMart. Everybody has heard of DMart, am I right? We go and buy stuff from DMart. Now, DMart has online presence, DMart has offline presence, right? And then like GeoMart or somebody, if you have Kirana Balas also, imagine you have different, devices which are processing your transactions. So device type 1 has date in the format DD, MM, YYY. Device type 2 has the transaction which has date in MM, DD, YYY. What am I trying to say is you have multiple data points coming in with different date formats. An example here, right? Now, when one is you need to ingest all of that data, right? How do you ingest? We will talk about. But then you need to transform that data, because you need to bring all the date formats into the single date format before you can store and then analyze. Right? So what is it that you are looking here on your screen? This is something we call as a data pipeline. Right? So this data pipeline is something that you will build when you want to analyze massive amount of data coming from disparate sources. Right? So how do you ingest the data is first question. Right? So for you to ingest your data, you need some kind of service. Right? One is, hey, you may need some kind of messaging system. Right? So for example, in open source world, everybody might be aware of something called as Apache Kafka. Right? Apache Kafka is a messaging service. Right? It gives us some of these capabilities very similar to Apache Kafka. What Google gives us is PubSub, publisher subscriber, very similar to Apache Kafka. It is for asynchronous communication. This becomes a place for your ingestion of data. Right? So your all disparate services, now going back to this slide, your mobile, your web app, your IoT, these all will become your publishers. And this ingest blue box that you see here, this will become your PubSub. right? So everybody will go come and publish their data point here, and then this will be picked up by a service which in Google Cloud could be, say, data flow, right? And data flow will pick up every message. So this yellow box of transform will become your subscriber here, right? So it will continue to churn or continue to eat all the messages, and then read the date, and then convert that date, store that data somewhere in a database, and then send it for analysis purpose or OLAP kind of situations, right? So that is where your PubSub comes in picture. It is basically for ingestion of data. It is a messaging service, right? It gives you durable storage. It gives you ability to have high availability because you can configure multi-regions in a multi-region mode, right? And how do you access? So you have way to access this using GUI, using CLI, using API call, right? Multiple mechanisms are there for you to use PubSub here. So publisher subscriber or PubSub is a service critically part of ingest, part of the data pipeline that we are speaking about, right? And this is your for messaging service, asynchronous communication. This becomes your useful capability. So for example, here PubSub as a service, HR system is publishing a message here on the topic which is HR topic. And these are all the services which are what? These are all your subscribers, right? So it could be employee directory service, it could be badge activation system, it could be email account provisioning. All of these will continue to look for, hey, there is a new employee who has got onboarded, and who published that information? It is HR system. But then once it is published, everybody else needs to work towards it, right? To welcome you in the organization, you need a new badge. So there is a separate application which is also looking for messages coming into PubSub, right? And these are what? These are two disparate services, but they all are hooked onto PubSub, which is one messaging service, right? And be able to work on this event driven kind of system where once the event happens, that a new employee information is published on HR topic, a badge will be activated, a email account will be provisioned in the facilities. They will be given access to access the doors and other services, and then employee directory will be updated that yes, a new employee has joined our organization, right? So think of PubSub very much useful for the similar situation. It's basically publisher subscriber, something that we were talking about. Now if you are building chat applications, you are building mobile applications, right? Search based applications, or ads and budgets that you are dealing with, right? These are some of other examples where you could think about using PubSub here, right? Finally, we have got only 5 minutes, 10 minutes left. Let me quickly take you through security, few more aspects, and then we will close. But before that, Akash, any questions are there so that I don't leave them for the last minute?
No questions as of now. So just general queries, and I'm attending to those.
Fantastic. Thank you so much, Akash. And I believe somebody is asking for feedback link. So yeah, we
Yeah.
would love to hear your feedback. We are trying to, compress as much information as possible in these 90 minutes. So we hope that this is really useful for you. So yeah, please provide your feedback, and hopefully this is useful for all of
And
you.
just for the interest of everyone and everyone's knowledge, we will share with you an email tomorrow. Uh, so that is within 24 hours, you'll have an email from Zoom, which will come up and which will give you the recording of this YouTube live session that we are having right now. And along with that, you can share your feedback using that email as well. So that will be available to you by tomorrow. Yes, Jiten, you can continue. Thank
Yeah, fantastic. Thanks, Akash. Okay, so talking about security, right? I mean, you can believe that if you follow a lot of security blogs, you will see that ransomware and then DDoS and DOS, these have made life hell for a lot of organizations, right? Security has become kind of top of mind for nearly everybody. Okay, and Google pays lot of attention to security, right? Because Google has like 10 plus services. I'm sure each one of you has a Gmail account, each one of you have access to Google search, YouTube, and whatnot, right? These each one of them have 1 billion plus users each. right? So you can imagine the kind of traffic and the kind of adversary situations that Google services could face, right? And Google pays a lot of attention there, right? So when it comes to security, think about it like this. When it comes to security, security of what, right? So think of each component. Don't think of security as one product that you can go and deploy. Think of security as, hey, when I store my data, it has to be encrypted. So security of data. Now, where is my data? It is not just at the storage layer, right? Data is also in transit. Data is also in memory. So Google actually gives you ability to secure your data in all three situations: data in transit, data at rest, and data in memory. You can encrypt your data in all three places, right? When you expose your service in a distributed architecture, application 1 needs to talk to application 2. So what I'm saying is, say it's microservice 1 talking to microservice 2. So how do you ensure that this communication is always encrypted? This communication is always authorized and is always authenticated, right? There are capabilities, right? How do you ensure that your internal employees, right, administrators, they are allowed only to operate safely? It means any inadvertent mistakes should not go and ruin your systems, right? So safe operations by administrators. For all of these situations, Google gives us certain capabilities. Now when you look at the tech stack, this is a layered architecture that you can think about here, right? Now in this layered architecture, what I want you to also leave as a thought process and as a homework, maybe, right? I mean, tomorrow and day after, over the weekend, when you find time, right, go and do a simple search. How Google ensures that hardware is secured, how services are secured, how user identity is secured, how storage services are secured, right? Google actually gives you lots of information, white papers, best practices, etc., etc., that will help you to understand how Google does at each one of these layers, right? So actually this all description is around the same. And then this is another thing which we have to understand very carefully, and this is my last slide to talk about here. So see, when we were in on-prem data centers alone until now, right, our thought process was, this is my data center, this is my hardware, and these are the services that I am running. So I felt responsible for security of everything in my data centers. But in last few years, what has changed is, it is somebody else's data center. It is a public cloud service that I am consuming from AWS or from Azure or from Google Cloud, right? Hey, Google is responsible for everything. I am responsible for my application. Not really. When it comes to security, how have you ensured application security? Have you made enough provisions to not allow any unwanted traffic, right? So when you look at the tech stack, right, in the on-prem data center, the one on the left hand side, the blue line that you see, right, you were responsible for everything. But when it comes to public cloud, your responsibility has not gone away. The yellow line that you see, Google is of course responsible for. Imagine, Google is responsible for security of the cloud. And what you are responsible as a Google Cloud user is security of everything that you bring into the cloud, right? You bring in an application, you create a database, you create a data storage bucket, you configure access policies, right? You are responsible for all of that. How do you configure access policies? How is your application behaving? What port and protocol do you open to let users access your applications, right? Because this is all something that is your responsibility. You are managing that, and therefore understand, when it comes to public cloud, it is a shared responsibility between us and Google Cloud that we have to worry about, right? So let me skip all of this part. Akash, do they get access to all of these slides?
Sorry, I didn't catch you.
My question was, do they get access to all of these slides
No,
also?
so we haven't been doing that in the past just because of IP and other intellectual property rights. So we do not share it with the learners. However, they have the YouTube recording, which will never be deleted. It's always available online, so they can always view those videos that they have attended or not attended.
Yeah, fantastic. Yeah, thank you so much, Akash, for clarifying. And yeah, thank you, everybody. I think it is already 7:25. I do not want to hold you beyond the time that you have given me. It was lovely talking to you, and thank you so much for all those lovely questions. Feel free to connect with me if you like to. And thank you so much, Akash and NASCOM, for
Yeah.
giving this opportunity.
So you have a feedback from Nitesh. It was a really great session and full of information. I really got a chance to get know a lot of new things. At last, thank you very much for delivering this informative session, and that is very true. It's been a lot of things packed in one session, and you rightly delivered it on time as well. So thank you, Jiten, a lot for that. Just a couple of things before we wrap up, and in the interest of time. So. The recording of this session will be available on the YouTube channel. So please search for Future Skills Prime on the YouTube and you can access this recording there. We will continue to do more programs like this and hopefully at a monthly schedule. That's what we are running at. Additionally, if you have any questions related to the course content, you can always feel free to write the email on support@quicklabs.com, which is support SUPPORT at quicklabs.com. And if you have anything in relation to not being able to access the platform or such, or any assessment related query, you can write it to support@futureskillsprime.in. So at the end, thank you so much, Jitendra, for taking out time and attending the learners. And learners, thank you as well for taking out time late in the evening, especially during your exam season, and attending the course. So have a great week, have a great evening, everyone, and a great weekend too. Thank you.
Thanks, Akash. Bye
Thanks.
bye.